So you can always define potential energy between 2 points, right? Potential energy between 2 points. But then if you were to have some reference, let's say the voltage at this point is, you want to have a reference point which is 0 volts. That 0 volts is what you call as a ground. The ground is at 0 volts. Where do you want to choose this location of ground? Typically you would choose it to be at an infinite point in space. That's the most convenient one you want to choose. If I were to choose that, then my potential at any point with respect to a point at infinity, my potential at any point at r with respect to infinity is going to be simply Vr minus infinity, isn't it? But V infinity is going to be 0. I have defined it to be my 0 volts conveniently. So then I become, the voltage at any point is simply negative infinity to R E dot dl. With respect to the 0 volts, how much is the voltage at R? So this becomes naturally easier. Then I can define between 2 points A and B, the potential between A and B, which is also called as electromotive force, EMF, between the points A and B, is going to be VA minus VB. Is going to be VA minus VB, which is the destination. Yeah, A is the destination, the location at A from B. So that's the source point. Consistent with what we had here. So you define your 0 volts to be at infinity. Then you can define what is the electric potential, what is the electric potential at any point in space. So not only electric field at any point in space can be done, now you can find the voltage at any point. And remember, this potential is a scalar because it's work done, and work done is force dot displacement. In some sense, this force is the electric field and this displacement is how much it has moved. So the work done is going to be the scalar potential. I take the stylus, I move it around, go up and bring it back to the same point. I have not done any work. So the work done is 0, right? Because the starting point and the final point is the same. So same thing. If I were to take any curved path and come back to the same point, that closed path integral E dot dl is going to be equal to 0 because the electric potential has not changed. That is true because electric field is a conservative field. It's called as a conservative field, also called as irrotational field. There are two ways of calling it. Both are the same, is conservative or irrotational. And in fact, it is this property that leads to the KVL, that Kirchhoff's voltage law, that the voltage across any closed loop, if you were to add it up, it becomes 0. The voltage around a closed loop should be 0. That's at the macroscopic level. So KVL arises because of this fact, this property of electric field being a conservative force field. From the electric field, you can define the electric potential. And once you define the electric potential, if your starting point and ending point is the same, in any closed loop, if I take, the total potential is going to be electromotive force. The total electromotive force is going to be equal to 0. The total electromotive voltage, not force, yeah, this should be 0.